Hello everyone and welcome again to my How To Education channel. As I promised you last week, today we are starting with How to Ace Finance, Introduction to Valuation, the Time Value of Money, Part 1. After watching this video, don't forget to leave me your feedback. Throughout this lecture, we will discuss the time value of money and tackle some questions such as: is $100 bill worth today exactly what it was worth yesterday? By this question, I don't mean to compare it to any other currency like the Lebanese pound, for example. I simply mean that if I borrow $100 bill from you today and give it back to you next year, will this bill be the only amount that I should pay you next year? If I borrow $3,000 today, how much should I give back in 2 years? If I want to have $60,000 in 20 years, how much should I deposit now? In order to answer these questions, there are some terms that we need to define. Present value of money. The present value is the value of a certain amount of money today. Let's say that you pay the bank $200 per month for your car. If you decide to stop with the installments and just pay the full amount today, you will be paying the present value. This present value will not be equal to the number of installments left multiplied by 200. It will actually be much less than that, and that's why the present value of money is also called the discounted value. We always refer to discounting when talking about the present value. The future value is the value of a certain amount of money later in time. Let's say that you borrow $3,000 to be given back in 1 year. The amount that needs to be paid after the time elapsed is the future value of money. It is highly unlikely that you will have to pay only $3,000 after 1 year. You will certainly have to pay more, and that's why the future value of money is also called the compounded value. The interest rate, which can also be called discount rate, cost of capital, opportunity cost of capital, rate of return, or required return, is the rate that determines how much this extra amount mentioned before will be. For example, if the interest rate is 5% per year, then at the end of 1 year, the person will have to give you back the $3,000 plus 0.05 times 3,000, which can be factorized as 3,000 times 1 plus 0.05 and written as 3,000 times 1 plus 0.05 to the power 1. In other words, after 1 year, the person has to give you back $3,150. Let's suppose that you borrow the above amount with the same interest rate but compounded for 3 years. Then the amount you need to give back will be 3,000 times 1 plus 0.05 to the power 3, which is 3,473. To generalize the above, when interest rate is compounded, we use the following formula. Future value equals to present value times 1 plus r to the power t, where r is the interest rate and t is the number of interest periods. The term 1 plus r to the t is called the future value factor. Pay attention to the fact that in both of the examples, we use the word compounded when referring to interest. Nevertheless, there is another type of interest, which is the simple interest. Before explaining the difference between compounded and simple, let's solve the example before using the simple interest concept. Finding the future value when t equals 1 will give you the same answer for simple and for compounded interest. Let's see how much the simple interest is when t is greater than 1. Let t equal 2. Then the future value will be $3,000 plus 3,000 times 0.05 for the first year plus 3,000 times 0.05 for the second year. In other words, 3,000 times 1 plus 0.05 plus 0.05, or 3,000 times 1 plus 2 times 0.05. Let t equals 3 now. The future value will be 3,000 plus 3,000 times 0.05 plus 3,000 times 0.05 plus 3,000 times 0.05, which is 3,000 times 1 plus 3 times 0.05, which is 3,450, which is different from 3,473, the compounded interest value. This shows that when t is greater than 1, simple interest is different from compound interest. To generalize the formula, future value of simple interest equals to present value times 1 plus RT. Simple interest is the interest earned only on the original amount, no matter how many years have passed. In the example before, we only calculated 5% of 3,000. We did not calculate 5% of any other number. Compounded interest is said to be the interest on interest. That is, when asked to find the future value of $3,000 after 3 years of borrowing, we use the formula future value equals 3,000 times 1 plus 0.05 to the power 3. This is equal to 3,000 times 1.05 times 1.05 times 1.05. We multiplied it by 1.05 3 times. This means that in the first year, we calculated 5% of 3,000, which is the original amount. In the second year, we calculated 5% of the new reinvested amount of 3,150, which is 3,000 times 1.05. In the third year, we calculated 5% of the newer reinvested amount of 3,307.5, which is 3,000 times 1.05 times 1.05. This is why we refer to it as interest on interest. In other words, interest not only on the original amount, but also on each reinvested amount. Not all the problems will be about finding the future value. Some might include finding R or T or present value. We will solve examples that include all the possibilities. Note that some professors might require you to learn how to use the financial calculator to solve some of the problems. Take a look at the financial calculator procedure below. The concept of future value and present value doesn't only apply to loans. It can also be used for investments. The example given before could be written in the following way. If I invest $3,000 today at an interest rate of 5% compounded annually, how much will I have in 3 years? The answer is future value equals 3,000 times 1.05 to the power 3, which is 3,473. If it were simple interest rate, the answer would be future value equals 3,000 times 1 plus 3 times 0.05, which is 3,450. Since t is small, the difference between simple and compounded isn't that large. Nevertheless, as t increases, the compounding effect will increase as well, and the difference between simple and compounded interest will be much larger. When solving present value and future value problems in the calculator, note that a cash outflow should always be preceded by a negative sign, and a cash inflow should always be preceded by a positive sign. That is, if we're talking about an investment problem, the cash that you invested is going out of your pockets, and the cash you will receive after a certain number of years is going in. So present value should be negative and future value should be positive. If we're talking about a borrowing problem, the money you borrow now is going into your pockets, and what you have to pay after a couple of years is going out. Thus, present value is positive and future value is negative. Nevertheless, this only applies to the calculator. When solving a problem on paper, all values should be positive. A common situation is when you invested or borrowed money in the past and want to see how much you will receive or have to pay today. In this case, the amount you invested or borrowed in the past is considered the present value, and the amount you will receive or pay today is considered the future value. Another common question is about the effect of compounding. That means, what is the difference between the future value using the compound interest and the future value using the simple interest? One can also refer to the equation future value equals present value times 1 plus r to the power t to solve other types of questions, as for example, imagine that you got a 60% on your first exam. Nevertheless, you aim to reach a 90% by the end of the academic year. The school year has 10 months, and you have an exam once every month. At what rate do you have to improve every month so as to reach your target by the end of the 10 months? Of course, in order to solve this problem, we're gonna use the future value equals present value times 1 plus r to the power t equation, such that future value is 90, present value is 60, and t is 10. Thus, 90 equals 60 times 1 plus r to the 10. When solving the following equation step by step, we find out that r is 4.14%. Therefore, your performance has to improve about 4.14% every month to be able to reach your target by the end of the 10 months. We use the equation of compound interest in this case, since every month the performance should be 4.14% better than the one of the previous month. So 4.14% is not only based on the original amount. Before moving on, please take a quick look on how to solve this using your calculator. Another example. Suppose that your boss decides to increase employment by 10% every year. Today, there are 22 employees at the company. How many employees will there be after 20 years? The answer is future value equals present value times 1 plus r to the power t. So, future value equals 22 times 1 plus 0.1 to the power 20, which is 148 employees after 20 years. This is it from finance for this week. But if you have reached the end of this video, it is because the content was helpful to you somehow. If this is the case, don't forget to give your friends and acquaintances the opportunity to have access to these videos by liking, sharing, commenting, and subscribing to this channel. We will be continuing with the second part of this lecture next Friday, but before that I will see you all on Monday with some derivative rules for the tangent u function. Thank you so much.